Hi, welcome back to our third lesson in 2.1 functions and equivalent algebraic expressions. In this example, we are just looking at simplifying some rational expressions. Once we simplified them, we then want to state any restrictions on the variable. Let's begin. So whenever we see something kind of complex like this, the trinomial, we should always think of trying to get this in a factored form if possible. So my factors, I'm going to write this off to the side. I need a product of 21 and I need a sum of 10. So I know that 7 and 3 are the only combination to get 21, and that actually adds to 10. So that's perfect. I got x plus 7, x plus 3. That's for my numerator. On the bottom, I got the denominator, I got x plus 3. So I can see I'm dividing factors, like I said in the previous video, and we can always cancel out common factors. So when these cancel out, it's not like I end up with a 0 on the bottom. When I divide x plus 3 by x plus 3, I'm actually just left with a 1. So this is going to be x plus 7 over 1, which is just x plus 7. So are there any restrictions? So when I simplify this and I bring it all the way down to here, it's kind of nice. I can take something really complex and make it just equal to this. So apparently this thing is actually just equal to x plus 7. So the thing is, there are some restrictions. So I can put anything I want in here, x plus 7. There's no restrictions for this. You can give me negative numbers, positive numbers, 0, don't matter. But here, we have to be careful. We can never divide by 0. So these two expressions are going to be the same everywhere, except this one is undefined at negative 3. So we need to state those restrictions at the end. So this negative 3, all this comes from is this denominator right here. Okay, there's no problems with the top, the numerator. You could put anything in there. So, and if all those values of x, like you could put anything into this expression and this expression, they're always the same. When you put negative 3 into here, this one's okay. It gives you 4. That's fine. But when you take negative 3 and you plug it into here, this becomes undefined. And that's no good. You can't have one expression undefined and the other one not and say they're the same. So when we simplify, we always just go ahead and check for those restrictions. And I always just scan the denominator. That's all you have to do. If I had more factors on the bottom, I would look through all of them and I would just list them. We'll see that in this example here. So this one, we now got some complex factoring. Okay, I said that with some enthusiasm. So that hasn't come up too often. So most of the time it's simple factoring. So now we got something a little bit complex because we have the 6 in front. So we can use the decomposition method for factoring this one. So that's where we take the middle term and we rewrite it. So we're going to rewrite it as two other terms. That's why it's called decomposition, because we take this term and we break it into two other ones that add up to negative 7. And then we do a little bit of grouping. So I'm going to write my factoring off to the side. So to do this one, it's kind of like product sum, but our product is actually the product of the first and last. So 6 times negative 5, that's negative 30. So my product needs to be negative 30. And I need two numbers that give me a product of negative 30, but add to negative 7. So I can tell here that I could do negative 10 and positive 3. That has a product of negative 30 and it has a sum of negative 7. So what that means is I can't factor this just yet, but what I can do is it's called factoring by decomposition, because we're taking this middle term and we're rewriting it using these two. Notice negative 10x plus 3 is going to be negative 7x. So, all right, we have 6x squared minus 10x plus 3x minus 5. So you can see the equivalency with this and this, right? Now we can do a little bit of grouping. So we kind of look for what's common between like the first two and the last two, and we factor whatever we can take out. So it's kind of like common factoring between these two. So I'll just highlight these a bit here. Okay, I'm writing this factoring out here, and then we're going to factor the numerator, and then we'll rewrite this later on down here. So if you want, you can do this factoring off to the side on your page. So what's the greatest common factor that I can take out of this first piece here? Well, I can take out, it looks like a 2 is going to be the greatest. So I can take out a 2 and I can take out an x from each term. Okay, from this one here, I can't take out nothing, just a 1 basically. So I can't take out anything from the coefficients, and there's no x term in the 5. So, all right, let's write this out. So we're going to have, let's go to blue. We're going to have 2x times, so I'm now dividing each one of these by 2x because I'm factoring 2x out. So 6x squared divided by 2x, well, 6 divided by 2 is 3, and x squared divided by x is x. Okay, so notice if you multiply these two, you get this term here. Negative 10x divided by 2x. We're going to have negative 10 divided by 2, which is 5, and the x's will cancel. It's be minus 5. Okay, my next one, I'm just going to leave it in brackets, 3x minus 5. Okay. So this next part here is, again, common factoring. So I can see what's common in this term and this term. The 3x minus 5 is common from both. So I'm going to factor that out. I would have 3x minus 5 times this here, 2x, and then times the coefficient there, which is just a positive 1. Okay. If you see, if I take this bracket and I multiply it into the first term, the 2x, I get this. And then when I multiply it with the last term, I get this here. So it literally was common factoring again, just to get this. If you have a hard time with this, or you just need to freshen up a bit, we do have the factoring videos that you can go back and watch. So that is this right here. So the bottom one is also decomposition. You can also do these by trial and error. So when you have a small number like 3 in the front and then negative 10, you can try a little bit of trial and error. But I'm just going to continue with the decomposition method. So I need to find two numbers that add up to 1 and have a product of negative 30. Okay, so we always take these first two, 3 and negative 10. 3 and negative 10, that's negative 30. So they were both negative 30. Kind of funny. So 3 and negative 10 is negative 30. I now need two numbers that have that product and a sum of 1. So I can do like 6 and negative 5. That would work. 6 times negative 5 gives me the negative 30. And those add to positive 1. So I'm going to rewrite this plus 1x as 6x minus 5x. So 3x squared plus x minus 10, this is just going to be equal to 3x squared plus 6x minus 5x minus 10. So that's the first part of decomposition factoring. Now we're just going to do the grouping part. So we just do a little bit of common factoring in those. So the most I can take out of the first part is a 3 and an x. And if I do so, I'll have x plus 2 inside the bracket. So again, I just factored 3x. That's the greatest common factor from these two. I can take out a 3 from each, and I can take out an x from each. If you distribute this in, you have this up here. Okay, the next one, I can take out negative 5, and I'll be left with x plus 2. If you're doing this procedure properly, you're going to get the same thing in these brackets. Okay, and because they're common, we can then do common factoring in the next step. I'm literally going to divide this out of both those terms. So we have x plus 2. So I always write what's common, and then I just grab what's in front after for the next bracket. 3x minus 5. Okay. Notice if you take this and you multiply it by 3x, you get this. And then if you multiply it by negative 5, you get this. Okay. that's the factoring for that. So we're left with this numerator was just this here. So I'm going to have this on the top, 3x minus 5 times 2x plus 1. And then this was my denominator, so I'm going to write that in here. X plus 2, 3x minus 5. Notice we got some common factors in here. Those will cancel out, okay? I'm only canceling them out because it's in factored form. Notice I never cancel anything out when they look like terms, like the x squared and the x squared. That's totally wrong. So don't ever do that. Only cancel out common factors. Oops. Okay. So we just have 2x plus 1 over x plus 2. That's fully simplified. So this here is a simplified expression of that here. Now those are identical. However, this one has a couple more restrictions than this one. So I always scan the denominators. So I can tell right here from looking at this, I can say that x can't be equal to negative 2 because that would make this 0, and we can never divide by 0. That's undefined. And then I can also look back in this line right here. This is when we had our factored form. It's our factored form of this before we canceled anything out. And notice there's one more factor here. So I need to investigate this one too. So 3x minus 5, what makes that 0? Well, let's write it down. 3x minus 5, we'll set it equal to 0. Let's solve for x. So we'll add 5 to both sides. We get 3x equals 5. Divide both sides by 3. We get 5 over 3. So that means x can't be negative 2 or 5 over 3. Okay. How do I know this? Well, if you take 5 over 3, and if you plug that into this up here, you're going to get 0. Okay. You could plug it into this one down here. That's fine. And also negative 2, if you sub that into this one or this one, you're going to get undefined. So basically the rule is when you're needing to state restrictions, take your original polynomial, or rational expression, get it in the factored form. Okay, this is our factored form right here. Once it's in factored form, look at all the factors in the denominator and check and see what will give you 0. When you inspect these, you can just write those restrictions down. Okay, so that is it for that example. I'll see you in the next one.